Hello. In this video I'm gonna talking about 20 questions that I prepared for the Red Seal 309A preparation plus solutions. You can follow my YouTube channel and you can find more videos about the Red Seal exam. Let's start with question 1. 75 kilovolt ampere dry type transformer has a primary voltage of 600 volt and secondary volt of 120 218 volt, 3-phase 4-wire. The transformer secondary supplies a panel board and no secondary overcurrent protection is installed. Only primary overcurrent protection is provided. According to the Canadian Electrical Code Book, what is the minimum standard ampere rating of the panel board? So for this question they ask us for panel board, size of the panel board. You can see the options. 260 is not standard panel board. 225 it can be 600 and 400. So one of these options, B, C, D, can be the answer. So for the secondary voltage, we have 75 kilovolt ampere. So dry type transformer. For this one, for dry type transformer, we can go to the Canadian Electrical Code Book and check it. You can find out about transformers in section 28. If you in section 26, in installation and electrical equipments, and you can find about the transformers here, and you can find about 2050 rule about overcurrent protection for power and distribution transformer circuit rating over. So here you can find about over 750 volts, 750 volt transformers, but in this question the voltage is 600 volt. The maximum voltage is 600 volt for primary, so we need to find for less than 750. So here is for less than, but here is other than dry type, because this question is about dry type transformer. So we go to the rule 26 254 and it is about dry type transformers and less than 750 volts. So here we can find out that for the overcurrent device we can add 125 correction factor. So let me, for this one's 125 correction factor. So let's come back to the question. So as you can see, the power of the transformer is 75 kilovolt amp. So it is dry type transformer, and the voltage is 600 for the primary side, and 120 and 218 volts for secondary. So let's calculate the secondary amp for this transformer. 75 divide 2, or let me to write it like this, 208. And this is the ampacity for one single phase, 360 of the transformer, but because this transformer is 3-phase transformer and 75 kilovolt amp is for 3-phase transformer, so when we want to calculate just one single of the transformer, we need to divide it on root of 3. So 732 is the root of 3, so equal to 208 amp. 208 is the ampacity of this transformer on the secondary side, and multiply by 125 because of the rule. It can be 260 because we don't have 260 panel boards. So the standard rate of the panel board is 225, and we choose this one as a standard panel board. And this is the answer. This is the answer for this question. Okay, so let's go to the question 2. 112.5 kilovolt amp dry type transformer is supplied from a 600 volt three-phase system. The secondary is 120 to 208 volt three-phase 4-wire. So this is the Y connection. Secondary conductors are 4 meter long and terminate in a panel board with no secondary overcurrent protection. So what is the minimum standard panel board ampere rate required? So again, we need to calculate the panel board size in the secondary size of this transformer. In the primary side of this transformer, we have 600 volts, and of course we have delta type, but in the secondary we have Y type because it is 4-wire. So and also you can find it from here because it is 120 and 208 voltage. So because of that, it is Y connection. In another video I described that why we have 120 and 208 at the same time for the residential usage or some commercial usage. We have 120 and 208, but in some another dwelling units or apartments we have 120 and 240 volts. And what is the difference between these voltages? I mean that let me to write it. In some cases, in some another cases we have 120 240 volts. And why we have this and these voltages are different. 240 120 they are the secondary of different transformers for dwelling units or for apartments, but these voltages are for different transformers, that they are three-phase transformers, but these are not three-phase transformers. These are transformers that we have two different voltages, 120 voltages, that they have different phase, about 180 degree differential in phases. So you can find out in one of my videos about this difference between the transformers. So let's go back to the question. Here you can find out about this question. Let me to bring my calculator. 112.5 divide for secondary 208. This is the voltage because this one is I divided it by 1000, so I divided the voltage by 1000. So this is the ampacity 540, and let divide it on 732, and this is because of the three phase, and make it for one single phase 312 amperage, and this ampacity 312 ampacity is for the secondary. And for this ampacity we can choose 400 panel board because the next standard panel board is 400. So this is the answer, correct answer for this question. Let's go to the question 3. three-phase squirrel cage induction motor. What is the induction motor? You know what is the induction motor. And the induction motors, they working with single phase 120 or 240 or 208 voltages, but they are single phase, and they work with single phase, but they make another phase with capacitor, and we have a rotating field inside the stator, and also we have the rotor that we have induction in the rotor, and the rotor is not the speed of the rotor is not synchronized with the speed of the field of the stator of the motor. So here we have this is the three-phase squirrel cage induction motor, operates as 582 rpm under full load. So this one is 582 is the speed of the rotor when the rotor is turning. This one is the speed of the rotor. Let me to write this speed. Let me here let me to name it NR. It means speed of the rotor is equal to 582 rpm, round per minute. So this is the NR speed of the rotor. But the motor sleep at full load is 3%, and the motor has 10 poles pairs. So we have 10 poles, and you know that in the induction motors, the speed of the field is depend on the speed of depend on the frequency, and also depend on the poles, pairs poles. So the speed of the induction motors, actually the speed of the field, it means the n. Let me to write like this. Ns is equal to speed of this one. Ns is the speed of field of the stator. So in this question we need to calculate the Ns. The Ns is the speed of the stator, but we can find out from the slip. How we have what is the slip? Slip is the difference between the speed of the stator and the speed of the rotor. But you know that stator is not a mechanical speed, it's a magnetic speed. It means that the magnetic field of the stator is turning because of the frequency of the windings and poles. When we have 10 poles on the stator, let me to show you in a photo. Induction motors field stator. The stationary outer combination contain winding powered by alternate current to the production of rotating magnetic field, RMF, rotating magnetic field. So this is rotating magnetic field, and the field NS. This photo can be useful. Copy image. Let me to put it here. Okay, rotating stator field. We have a stator, and the stator mechanical is not, we know that mechanical is not turning, but the magnetic field of the stator, because of the winding and because of the current, AC current, is turning, depend on the frequency of the power, frequency of the current, and also depend on the poles of the stator. So we have turning NS. See, look at here. NS is the turning of the field, and the rotor is starting to follow this speed, but it's mechanically turning. The rotor is turning mechanically on the shafts, but because of the turning of field, we have induction in the conductors of the rotor, and because of that we have current in the conductors of the rotors, and also because of that current we have another field, a small field, because of the rotor, and this field follow this field. The big field is the field of magnetic field of the stator, and we have another induction field in the stator, in the rotor, and in the conductors of the rotor, and the field generated magnetic field because of the current in the rotor, in the conductors of the rotor, started to follow the magnetic field of the stator. So now in this question we want to calculate the speed of the stator or speed of the magnetic field of the stator. So how we can calculate it? We have a slip. What is a slip? A slip is the differential of the speed of magnetic field, the speed of the stator, and also the speed of rotor. So let me define the slip. What is slip? Slip is like this: ns minus nr, speed of magnetic field of the stator minus speed of the rotor, divide ns. So this one is the definition of the slip. We use slip is one of the characteristics and definitions of the motors. You can find it. You can find the curve and also definition of the slip for the induction motors. So this is the main mathematical formula of the speed or slip. And what is the slip? The slip is depend on the speed of the magnetic field of the stator. Let me to here we have also, we have another formula, mathematical formula about the speed of the stator. And what is the speed of the stator? It is about 120 by f. F is frequency of the current, frequency of the voltage or power, electricity power of the stator, and divide per p. What is the p? P is the poles, pair poles. So let me to write here in this question, p pair poles is equal to 10. We have here, we can find it here, the question telling us the speed of the number of the poles are 10. So p is 10, and we are searching the question asking us about the frequency of the current of the stator. So we want to find this f. How much is this f? So let me to get this question. But we don't have an ns, so we have the f, we don't have the f, we have the p, we don't have the f, and we don't have the ns. But if imagine that we have the ns, so I want to get the f. So f equal, if we put the p in this side of the equation, it's go on the top, and it should be like this. F is equal to p multiply ns, and if this 120 go to this side of the equation, is go under the division, so it's like this, divide 120, and let me to put it on the brackets like this. Okay, and so we can get the frequency from this f, and this is the main equation. And let me to make it a little bit bigger. Okay, and this one is main equation. You can find these equations in the electrical machines or electrical motors documents books. and box. So here we have the S. Depend on the question, we have the S. S is 3. Let me to write here. What is the S? S is equal to 3% or equal to 303. So we have the S. And also we have NR. Also we have NR, we have the S, but we don't have the NS. Let me to take out the NS, because in this equation this is the main equation, but we need to take the NS. If we want the NS, it is like S equal to NS divide NS minus NR divide NS. We can write this equation like this. And we can write it like this. NS divide NS is like 1 minus NR divide NS. So we have the S, so we need the NS, so we can write it like this. NR divide NS equal to 1 minus S. I bring this S to this side of the equation, and also bring this minus NR, negative NR divide NS to that side of the equation, and make it like this. And also we need NS under the division, so we can write it like this. Bring it to that side and bring this one to this side, so we can write it like S. NS equal to NR divide 1 minus S. So this is the new equation. Let me to write it again here clearly. NS equal to NR divide 1 S. So this is the new equation, and we can use it for this kind of answers when we have the slip and we have the speed of the rotor. Like this question, they tell us that the normal induction motor operates at this speed, so we can use this equation and we can write it like this. So we can get NS equal, what is the NR is 582 divide 1 minus 303, and is equal 582 divide 97.97. 582 divide 97, 600 is the speed. Okay, so RPM, round per minute, is the speed of this magnetic field of the stator. So magnetic field of the stator is turning with the speed of 600 per minute. When we connected it to the power, electricity power. So now we can use this NS in this equation. In this equation, where is NS? For this equation, we need NS and we need P and F. For this equation, here. So we need to know how much is the F. So F is equal P. What is the P, it is 10. 10 by NS was 600 divide 120. So 6,000 divide 120 is 500, 50, because 50 are hertz. Okay, so this is the answer. 50 is the answer. 50 hertz is the answer. This one is our answer, and we can use these equations. This equation F is this one. This one is good equation. We get this equation from this equation, and S is equal 120 by F divide P. And also this equation NS, this one, NS is equal to NR divide 1 minus S. What is S? It is the slip. So let's go to the next question. Question 4. A three-phase load draws 41 amp at 208 volt on a three-wire system. What is the minimum the standard transformer kilovolt amp rating required to supply this load? Options. So options 24. A three-phase load. We have a load draws 41 amp at 208 volt. So this is the three-wire system. So because it says that this is the three-wire system, the three-wire system is delta connection load. So it is a delta load. So let me to search it. Delta load. Delta load, like this one. This one is delta load. Copy. This one is delta load, and for delta load, this we can imagine this load is in a box, and we just have 3 wires out of this box, and each of these wires draws 41 amp. So when this 41 amps coming here, we have 2 wires go to the each side of the load. So we need to divide it by root of 3. So if we want to get this current, we can say that 41 divide 732 is root of 3, and this is 23.7. 23.76 equal to 23.24 amp. Imagine 24 amp for one phase of this load. So because this question tell us 3-wire system, so I use this combination of the load, 3 different part of the load that they are connected together with delta connection. And also we have 208 volts. 208 volt from this point to this point, 208 volt from this point to this point is 208, and also from this point to this point is 208 volt. So when we want to calculate the power of this, how much power needs this load, ZA, so we can multiply the ampacity of this load by the voltage of this load. What was the ampacity? 24. Imagine 24, and it is by 208 volts, so it should be 4,923 watts. It is the or volt VA, volt ampere. So For each of this part of the load, we have three phase load, and that it is delta connected. So for each, it is like 5 kilovolt ampere. So for each of them, imagine 5 kilovolt ampere is close to the 5 kilovolt ampere by 3. It can be 14 kilovolt ampere. So this is like this answer, 15 kilovolt ampere. It is the totally load of this three-phase load. So minimum standard transformer, what kind of transformer we need? We need a 15 kilovolt ampere transformer is enough for this load. So this is the answer. And that's it. Let me to write the equations. First of all, the ampacity of one phase is equal to 41 amp divided by 1732 root of 3. So it was 24 amp. And after that, what is the load volt? S is equal to SA. Let me to write it SA. How much this part of the load needs. So it is VA by IA, and this is IA actually, IA equal to I phase, and it is 208 by 24, or we can write it 25 amp. It's close to 25 amp, or let me to write it 24, and it's equal to 208 by 24. It's 4.9 kilo. It's actually equal to 5 kilovolt amp. And for full load, for three-phase full load, its S is 5 SA plus SB plus SC. For each of these loads, SA, SB and SC is equal to 15 kilovolt ampere, and this is the answer. Okay, so question 5. 100 horsepower cumulative compound DC motor. So compound DC motor, we have DC motor, and we use 500 volts for run this motor with the efficiency of 78%. So let me to we have a table. What is the calculated full load current? And this question asks us for full load current of this DC motor. We have in Canadian Electrical Code Book, we have a table. We call it table D2. This table is for DC motors, and full load ampacity of the full load motors, DC motors. Let's go and find out about table D2, appendix D. Look at here, D1 type designations, voltage rating, and construction of wire and cables other than flexible cords. So you can find out some details about the cables. And also D2 is about DC motors, and also D3 is about the voltage drop. So table D3 is about voltage drop, D2 is about DC motors, FLA of them, and D1. These tables are most important tables in Appendix D. Yes, this one is about some features of the wires and cables. Okay, so let's go just for review. Let's go to the table D2 for DC motors. DC motors, we can find them about them in table D2. Table D2. So what was the horsepower? It was 100 horsepower. So here, and for what voltage? 500 volt. So for 500 volt, the last column, and 100 horsepower. 165 is the ampacity for this DC motor. For this DC motor, 165. But let me so from this table, let me to write it from this table. We got that 165 amp is the ampacity of this motor, and this is the answer, but it is the fake answer. It's not the correct answer. Let me to make it like this. This is not correct answer. Why? Because when you go to the Canadian Electrical Code book, you need to be careful about the notes under the tables, because some notes change the conditions, change everything, and maybe you will get fail in your exam. This exam is difficult because of this exemption, because of these notes. These values of full load current are being used as guide only. These ampacity are just for guide. It's not the correct reference. Why? Because these are totally is average of this. For example, 40 horsepower motor under the voltage of 120. This is the average voltage for motors, but motors are different. For example, all 1 horsepower DC motors in the market are not same. They are their factories, the producers, the suppliers have different kind of DC motors, and because of the correction factor, because of the efficiencies, because of the producers, some producers are good producers, some are not, and because of the quality of the material of the core of the motors, because of the quality of the winding, because of everything, they have different efficiencies. And in this question, when they give you the efficiency of the motor, 78% of the efficiency, and also you have the efficiency, and also you have one more thing. You have the voltage, and you have the horsepower of the motor. You can calculate this without using this table. You can calculate it when in electrical motors. When they are talking about the horsepower of the motor, they are talking about the mechanical power of the motor. When we see that this motor is 100 horsepower, it is the mechanical feature of the motor. It is the output power of the motor, because they write it in horsepower. So I can tell you that this power is P out of the motor, and when they wrote it in horsepower, HP, it is the mechanical power. Imagine that the motor is a black box, and we don't know. It's not important for us what is inside the black box. We just know about the output of the black box. The output of the black box is 100 horsepower, and the input of the black box, we don't have any idea what the input, how much power we give to the motor or the black box, but we know that this black box have the 78% of efficiency. So we know how much is the output power of the black box, and we know the efficiency of the black box, so we can calculate the input power of the black box. So for here, let's to convert this 100 horsepower to the watt. P out, when we want to calculate in the watt unity, we can multiply it by 746 watt. This 100 is on the scale of horsepower, so I need it in the watt scale, so it's 74610 here, no, 20 here because of this 100, and it's like 74.6 kilowatt. So we have a DC motor that the output mechanical power of this motor is 74.6 kilowatt, and we can let me electrical motor convert the electrical energy to mechanical energy. Okay, so here what is the DC motors, electrical motors, maybe this photo, we can use this photo, kinetic energy, that it is mechanical, electrical energy coming to this motor, and yeah, it shows that, and let me electrical motor efficiency, okay, efficiency of the electrical motors. Okay, motor output in watt, motor input in watt. We have CU losses like we have some losses in the coppers, iron friction losses. We have some losses in the material of the core of the in the stator or rotor of the motor, and so we have some losses. So when we are talking about the efficiency, mechanical efficiency, electrical efficiency, C divide B or B divide A. You can see driven power in armature. So in total, the efficiency is the C divided by A. Let me to show you some more photos. Electrical motor efficiency. This one show you that the different kind of motors and what is the different of their efficiency. So yeah, so I just want to tell you that you can calculate the input power of the motor by the efficiency of this motor, and also the output power of this motor. So maybe better searching P in, P out efficiency. Maybe here I can find better photos. P in, P out efficiency. Yeah, look at this equation. P in P out divide efficiency. This is, and it's not just for motors. Efficiency, you have efficiency for every human or not just for human produced products. Everything has its own efficiency, like solar panels, like motors, like your vehicle, your engine of your vehicle, efficiency for everything that you have. As a human, you have your own efficiency. You have output, you have input, and the efficiency is how much you make good output related to your input. So let me to P efficiency. If we show efficiency by E, its efficiency is P out divide P in. So here we need P in because we don't have the P in of this motor. We have the P out of this motor. It's like 74.6 kilowatt. If we want to calculate the P in, we can write it. We can change this equation like this: P out divide efficiency, and it's equal to P out. P out, how much was P out? 4.6 divide efficiency was 0.78%, and so we can calculate it. 4.6 divide 0.78 is 95. It's like 95.6. It's like 96. Let me to write it. 96 kilovolt ampere. Also we can write it kilowatt, no problem. So 96 kilo, because in this question they tell us about the efficiency of the motor, but they didn't tell us about the power factor of the. So here we assume that the power factor is 1, it's unity, and here I can write it kilowatt or kilovolt ampere, no different, because we assume that but if they're talking about the also they put the power factor of this motor, we need to assume we need to add it to our calculations. Okay, so we have the input power to this motor, and we have the voltage in this motor, so we can get the ampacity. Input ampacity of this motor is equal to P in divide V in. So it's like 96 kilowatt divide 500. Let me to write it here. It's like this. Now volt, and it can be like this. I divide them by 1000 and divide them to 1000, so we can write like this: 5, and it's 192 amp, and it is this option is correct answer for this question, and 191 is the answer. So it is 191 or it was 192, but because I changed it, it was 95.6, and no problem, it's the answer. Like to change it like this and like this. Okay. Question 6. Which statement correctly described an NPN transistor? What is the NPN transistor? In transistor, this is the negative transistor. We have two different kind of transistors. Negative transistors like NPN, and positive transistors like PNP. And what is the P? We have anode in transistors. We have anode. That anode is we show it with P in transistors, and cathode we show it with N. So here is NPN. So we have, it has two cathodes and one anode. It has only two terminals. Now in transistor we don't have just two. The emitter is a cathode. The emitter is cathode, and it consists of three semiconductor layer arranged NPN. Three semiconductor. This one is correct. We have three semiconductors. Semiconductor N, semiconductor P, and semiconductor N. So this answer is correct. Three semiconductor layer arranged NPN. Yeah, because and this is the negative. So this can be the answer. But I think this question has three correct answers. Emitter is cathode. Emitter, base, collector. In transistors we have three different leads: emitter, base, and also the emitter is cathode. The emitter is N and N is cathode, so emitter is cathode. So also this answer is correct. It has only two terminals. No, this one is not correct. This answer is not correct. And it has two cathodes and one anode. So also this one is correct. It has two cathodes and one anode, because two cathode and one anode. So this question has three answers. Maybe we can change this question in which statement is not correctly described. If we write it here, not correctly described, so this B can be the answer. Does not describe an NPN transistor, and this one can be the answer. But if we don't have does not, so we have three right question answers. I think we need to add does not correct. There does not correctly describe the NPN there, so this one should be the answer. Let me to make it bigger. Okay, question 7. Let's go to the question. On which type of the drawing would an electrician find information related to PLC software programming? I'm gonna record another video about the PLCs and the ladder schematics, and schematic of this PLC software, and also logic software of the PLC programming, because in some questions in electrician red seal exam you have some questions about the schematic of the PLC, and also about how to read the circuits of the PLCs. So I'll make another video about the PLCs, but you can find out in my channel in few days. But for now, for PLC, it's talking about the software programming of the PLC, because it's talking about the software programming of the PLC. For software programming, we can find it in schematic drawing, layout drawing, and logic drawing. Logic diagram, you can find out the logic programming software of the PLC in logic diagram. Question 8. An electrician must use a powder-actuated fastening tools. Which combination of the materials is acceptable? Okay, for powder-actuated fastening tools, you can find because these tools are strong pulls to put some steel or wood or some nails to the tough walls or tough materials like concrete. So this one, steel to wood, is not. This one is the answer, just this one, because we use this powder actuated fastening. This powder actuated is a chemical powder that is make a combust and make a big energy to push for example, wood in the concrete. Okay, let's go to the question 9. Which condition indicates a properly functioning diode? So diodes are electronic diode symbol meaning diode. Okay, this is the diode. Copy image. What is the diode? We have cathode and anode in diodes. Anode is positive, cathode is negative, and this arrow show the direction of the current, conventional current, direction of the current, and this white stripe show the cathode side of the diode. And what is the functioning diode properly? High forward resistance? No, in forward resistance we don't have forward bias, we don't have high resistance. If the diode is on, electrically on, the forward resistance is low. Low reverse resistance? No, it's not correct. The reverse resistance of a diode is high, so this option is not correct. Low forward resistance? Yeah, this statement is correct. Low forward, when in forward direction the resistance is low, and high reverse resistance in reverse direction, yes, the resistance high, so this can be the correct answer. But let's go to the C. Low forward current. Forward current? No, when the diode is on, the forward current is high. And low reverse current? Yeah, this one is correct, but the C, because of this one, is not correct. High forward current and low reverse current. High forward current, yeah, this one can be true. Low reverse resistance? No, this one cannot be, because the reverse resistance is high. So this one is the correct answer for diodes. Also, you can let me to make a statement. You can have more courses and classes with me if you want. We can have online classes. I have some students that they want to get their electrician license, Red Seal 309, and I have lots of students. They have classes with me, with online classes. If you're interested to have online classes, you can contact me in this comments of the YouTube video, or you can contact me in another ways. You can send me email, and we can schedule a time for our classes, and I'll teach you in better ways and better, and we can have more questions for be prepared for your exam. Let's go to question 10. 6,000 watt 240 volt electric hot water tank is connected to a 120 volt supply. What power will the heater consume? Okay, so for this question we have the power consuming of the electric hot water tank for 240 volts. So if we connect this one to this voltage, so the voltage is not working. If it's 240 and we connect it to, it's not working actually. It's not warm up the water, but We know that P, the power of electrical equipment, how much they consume, the electricity is equal to VI, the voltage multiply ampacity. But also we know that if we don't have the ampacity, if we have the resistance, we can write it like this: V by I. Let me to write it I like V divide R. We can write it, correct? So we can write it V to the power of 2 divide R. Here the voltage is divided by 2. So this voltage divided by 2, because we have the power of 2, it would be 1 divided by 4. So the power would be 1 divided by 4. We'll divide by 4. So if we plug this device to the 120 volt, the power of this device, the amount of power that this device produces is just this 6000 watt divided by 4. So let me 6000 divided by 4 is equal 1500. So this is the answer. So because of that, I'm telling that it's not working. It's just a question, but in real world we can use a device in 120 volts when the real amount of the device is 240 volts, and it cannot warm up the water. During a large construction project, electrical installation changes are required. Electrical installation changes, we need electrical installation changes for large construction projects. We have a large construction project. For large construction projects, how must these changes be officially documented and tracked? It says that how they officially documented and tracked. Verbal commitment, no, verbal is not working. Weekly site meeting with formal written approval, yes, this one. Handwritten notes on drawing, no, it's working, but for small projects, not for informal sketch, no, not informal. It says informal sketch updates is not working, so the B is the right answer. So let's go to the question 12. When determine precise receptacle and switch locations, which drawing provides the requirement dimensional information? Electrical drawing. You can find out in electrical drawings about the locations of the receptacles. Electrical equipment is considered approved when certified by which of the following? When we want to have approved label on electrical equipment, we need to refer to a Standard Council of Canada and accredited individual, no, not accredited individual, recognized certification organization, yes. An authorized supervisor, no, an authorized supervisor. This one and this one, but for this question you can't find this question in the Canadian Electrical Code book, but totally the certification organizations can make approved labels for electrical equipments that when you want to install or you want to buy them from the market. Where is the current transformer CT normally installed? Where? So CT current transformers, we use this current transformers for measure the ampacity of a line or a wire. Let me to show you the internal CT measurement or CT transformer Okay, these ones are CT transformers. We use these ones. Oh, let me to show this one. Also, this one is good one. Copy image. CT transformer. A wire, big wire, past this hole with high level of the ampacity. For example, if you have, I don't know, 500 amp, 1000 amp, a lot of ampacity, you can't measure this ampacity with small devices or ordinary measurement instrument devices for measuring the ampacity. Normal thing is we use the CT. It is like a transformer. It has one primary winding and secondary winding with lots of turns. So the rate of the ampacity will be very low in the secondary, and you can measure it. We have another. This one is good. Copy image. Okay, working of current transformer, secondary winding. This is the main wire that it has a high level of the ampacity, but this transformer put another with this clip. Put in this clip. When you close this clip, the magnetic field can flow in this clip and come here, and we have secondary winding here, and the secondary winding make a low level of the ampacity. And you can see here, this is the main. It's working as a primary winding. This conductor work as a primary winding, and this one is the secondary winding, and this is the measurement. So CT. So this question telling us what is the normal insert, where is the in a metal enclosure only, inside the transformer switch, in a meter socket or metering installation on a high voltage load. This correct answer is metal enclosure. We need metal enclosure to put the CT in it. Okay. Question 15. If a metal cable tray is not bounded to the structural metal frame and TC cables are installed, which statement is correct? The cable tray, we have cable tray, we installed TC cables on them, and we don't have any bounding for the this metal cable trays. So it's asking that what the statement is correct for this situation. The cable tray provides sufficient bounding. Provides no. This says that no bounding for the cable tray. A separate bounding conductor for the TC cables is required. Yes, because TC cables, we don't have TC cable. For TC cables, we don't have bounding conductor. So TC cables are like this. TC cable like this, and we don't have bounding, so we can use separate bounding. Bounding jumpers must be installed every. It means that we can install bounding jumpers every 5 meters for the cable tray. Metal sleeves must be used to add supports. Let me go to the Canadian Electrical Code Book. It's about cable tray. You can find out about cable trays in section 12. So cable tray, section 12. We can find it about it, but it's about bounding of them. So when we refer to the section 12, we need to search for bounding of the cable trays, or maybe we can find something about TC cables. I don't know. Metal frame. This is the words that we can search for them. Let me to go to section 12. Section 12 is about wiring methods, general requirements. I need to go more faster. Let me to use the scroll because it's not here. Underflow, auxiliary gutters. Maybe it's here. Auxiliary gutters, wireways, cable tray. Yeah, cable tray. So you can find about cable trays, method of installation, insulated conductor and cable in cable trays, insulated conductors like TC cable. Yeah, you can find type TC here, TC cable. 1/0 AWG if the single conductor cable is used. Cable tray. About the bounding, let me to find out about the bounding. Okay, this one is about the bounding of the cable trays. Okay, this is the 15-meter metal cable tray shall be bounded at intervals not exceed 15 meters. So it is about the cable tray not 50. So this question, no, that was 5 meters, so it's not correct. But here metal armored cables or continuous metal shed cables only. The equivalent plans a continuous position with maximum spacing of warning notice. It is about the warning notice of the cables not exceed 10 meters. I've seen this kind of questions, but okay, so the correct answer is the cable tray provides sufficient bounding, a separate bounding, because these cables don't have the conductor. This can be the correct answer. This one should be 15 if we want to use bound the cable tray, and bounding except the provide support to a metal cable shall be bounded interval not exceed bounding 15 meter ampacity of the largest underground as sufficient rule where metal support or board try input electrical where cable tray are connected other arranged B shall be insulated conductor cable not subjected to mechanical damage. Okay, yeah, that one is the correct answer. Question 16, which situation permits to supply services of the, so it's talking about the services, so it's related to section 6. You need to know everything, you need to memorize. Supply services is in the section 6. Same voltage, it's talking about the same voltage for the entrance voltage of the building, one building. We have one building, it's talking about can we two supply service? Generally we can't have two supply services for just one building at the same voltage. If the voltage is different, no problem, but if the same voltage, no, we can't use. But there is some exemption for this rule. Let me to go. So section 6 is about the services. Section 6, services and service equipment. And same voltage. Look at here, same voltage. Number of the supply services permitted. 2 or more supply services of the same voltage shall not be run in any building. It's not acceptable to run same voltage from two different sources in two different cables coming to one building, but there is exemption. If we use it for fire pumps, no problem. Industrial houses or industrial locations or buildings, no problem. Or completely self-contained occupancy where the occupancy are not allocated one above the other. If they are not above to each other, have a separate entrance, is acceptable. Okay, so it's acceptable if separate occupancy with ground level access, separate level access, and that are not above another. So this one can be the answer. In emergency sump pump, no, it's not sump pump, it's fire pump. It's fire pump, yes. It's separate service boxes in different locations, no. Occupancy is located on above other, no, not above other, so it's not located on above other. And separate entrance, so this one is the answer. What is the maximum permitted ground fault protection set for submersible lake pump? Submersible lake pump, about submersible lake pump, you can find out about more submersible lake pumps in section 26. You need to memorize that each section has what kind of information, and because in the exam you don't have enough time, you need to find out, but there is some structure, there is some rules. After a while of working, if you mentor good, in good position, you can find out that in what kind of information you can find in each sections. Okay, sub pump, submersible lake, maximum permitted ground fault. What is the maximum permitted ground fault protection? Ground fault protection, we need to find out about the maximum, about the submersible. I know that submersible lake pump, submersible lake pumps, you can find about them in the section 26. But let me to test the index, maybe. Submersible lake pump, submersible lake pump, submersible pump 26. Okay, here 26 956 is the rule for submersible pumps. So but it's kind of waste of time. It's better to be your own index and your own context. Okay, it was 900. You don't have enough time at the exam. It's difficult. You need to be fast. Grounding, 5026. Why I'm here? 26. 26. Submersible pump in installation, deep submersible tower installation, submersible pumps. Submersible pumps, look at here, we have submersible pump here. You can find out about them here, about the cables, about the wiring, submersible pump installation, about bodies of water. Okay, ground fault correct, current 10 milliamp. And the next one is data processing. Okay, 100 volt of this trick for studying this book. When you are searching for, you have time before the exam, you have time and you want to search about the question. For example, I come in here and find out, oh, look at here, it's ground fault of the submersible pump and 10 milliamp. But also I'm looking from another thing. Maybe I found out here 150 volt to ground not exceed. Maybe another, because this book is big book, a lot of information there is in book. You can't memorize all of them, but it's you need to memorize the ways, the structures, the ways of finding information in this book. So when I came here for ground fault current, I've seen, oh, okay, here 150 volts to ground for the submersible. The voltage supplied the submersible pump shall not exceed. Do you know why shall not exceed? Because it's working in the water. So it's a rule. The rule tells us that we don't we're not permitted to use 150 volts, more than 150. Okay, let's go back to the question, and this it was okay. And also we have this one for dueling unit for ground fault interrupting circuit interrupters, GFCI circuit breakers for receptacles. This is between 4 milliamp to 6 milliamp. For some devices we have 20, for some 30 milliamps, different milliamps for ground fault protection. Grid mat is installed over 150 mm of the crushed stone. Okay, let's see what is the crushed stone. 150 crushed stones. These are crushed. Most of the time we use these crushed stones in some high voltage stations, base, in telecommunication, the power stations, different, because these ones they make high resistance for the ground. It's good for the stations. They are good. And install grid mat. What is the grid mat? We use these ones also for safety in the high voltage stations, because these ones they have the high resistance. It's like carpet under your foot, and they have high level of the resistance. Electrical, yeah, these ones, we use these ones under your foot. Okay, here, copy image, paste here. We use these mats for electrical works. Okay, so moist soil. It's talking about moist soil, high voltage substation. You can see high voltage substation. When we are talking about high voltage substations, we need to talk about the tolerable step voltage. What is the step voltage? The step voltage is very important phenomenon in high voltage substations, and also for lightning. When we have lightning or arc fault in high voltage substations, for in telecommunication stations on the peak of the mountains, we have the continuous lightnings every maybe seasons. So and these are important step voltage. Let me to find out about step voltage and also touch voltage. What are these ones? Top voltage, touch voltage. These are very important. They can cause of killing someone. Why? Because this is when we have lightning, or we have arc fault, or big fault, electrical fault in a point in a ground. The ground can have a lot of electrons in them, and we have a big voltages. It's like gradient voltage. When you making step in this, the high voltage can be between your foot. From your back foot to your forward foot, it can be high voltage of potential and also electrons, and they can kill you. So it is very important to be careful about the step voltage and also touch voltage, because in touch voltage, you think that this steel of the towers are insulated and they grounded and they don't have voltage and ampacity, but because of the ground fault or because of the lightning, all the ground is full of electrons, so they can be very dangerous. Look at this photo also, different voltage because of the difference. So it's also danger for big animals like cows or buffaloes, because they have big body. and the distance of their body is more than human. Also, it's danger for human. Copy and and okay. What so for this question we have a table. Let's go to this. When you see this one, we have a table for this. For high voltage substation, for crushed stone 150 mm, for moist soil, when we are talking about a step voltage, we have a table. Table 52 is for this one. Table 52 is about step and touch voltage. Okay, let's go to the table 52 in the Canadian Electrical Code Book. Table 52, totally understand. He totally understand. Okay. Table 52 is about tolerable touch and step voltages. So it was here. It was like a 150 mm stone over moist soil. So this is our answer. And step it's about step voltage, not touch voltage, and it's about half a second. Because of that half a second. So step voltage, it can be 2458 volts. So if you just make a step, you can immediately die because of 2.5 kilovolts. It's too high. It will kill you. Okay, so this one is the correct answer for this question 18. Let's go question 19. A low voltage surge protective device SPD is installed outdoors at the consumer service and must be at least one for. So which additional installation required? Okay, low voltage surge. Okay, it says surge protective devices. You need to know where are the surge protective devices, which when we're talking about surge protective devices, you can find about them in section 26 because it's like electrical equipment. These equipments are for protect our system, our electrical system, our panels, our equipment, electrical equipments, everything, cables, our nuts or connections, splices, everything, especially control systems from the high voltage electrical services. We install these ones on peak of the mountains, in substations, and in telecommunication or electrical power transformer, high voltages in the towers, because maybe lightning coming to the electrical services, and these devices filter the high voltages to the ground. They pass them to the ground, but they don't pass the low voltage to the ground. So surge protective devices, it's like circuit breakers. These devices are like circuit breakers, like this one, this one. Copy image. We install these devices for protect the electrical equipments against the high voltages from the lightning or from the spikes. Install at the service head, install on the line inside of the meter socket, install at any supply point of the overhead distribution, install on any outdoor distribution enclosure, supply from the overhead distribution. Let's go to the book and find it. Let me to find it. Section 26. 26. Okay, we want to find out about the surge arresters, lightning surge arresters, how they protect our equipment against the high voltages that come from the receptacles. Surge arrester. Maybe we can use the index lightning arrest. Oh, lightning arresters. Yeah, this one's lightning arresters or surge arresters. Same. Surge arrester, lightning arrester. Okay, for this one, low voltage surge. Oh, low voltage. We have also low voltage surge because the question was about the low voltage, I think. Low voltage. Yeah, it's low voltage surge arrester. So okay. So for low, it means low voltage surge arresters. It means that we use these devices, these electrical equipments for the dwelling units, for the apartments, where we have, because sometimes lightning hit the power cables in distribution systems when the cables in between the poles run in the spins between the lightning hit these cables, and the high voltage of power electricity coming to these cables, and somewhere they need to go to the ground. If they don't go to the ground, they coming to our houses and destroy everything. So in the connection of our houses to the distribution system, we can use this low voltage surge protective devices to damp this high voltage. So at the service head, except as provided sub rule where low voltage surge protective devices are to be connected to the consumer circuit, they shall be installed outdoor at least 12. It was in the question, this number, it was in the question. So we can be sure that we are in the right point of the at the service head supplying the consumer service, at the service head supplying at any supply point of the overhead distribution on the load side of the self-contained utility meter socket, at the load side of the this one. Okay, here at the load meter socket. So I think here we had this one, meter socket. We had meter socket, so we can install on the meter side, but at the load side, on the line side, no, it's not. Oh, it's not correct, because it says that at the line side, but here it says that at the load side. So it's not used. It's not. Install at the service head. Install at any supply point of the overhead distribution. At the service head supplying the consumer service. At the end supply point of the overhead. At supply point. Any. So it's not any. So it's not correct. It says that any. So it's not correct. So at the service head supplying the consumer. So this one can be the answer. Install at the service head. And it's correct. It's logic. I can sense. It makes sense for me, because I'm telling that at service head is the first place that the electricity comes from the utility to our house. So it's the best place to install the surge arrester, low voltage surge arrester. Question 20. For an overhead service to a single dwelling unit, we have a single dwelling unit overhead service. What is the maximum horizontal distance? Maximum horizontal distance. So it's horizontal distance or allowed to point where conductors emerge from the service head. So they come from the service head. The conductors from the utility come to our house. Oh, support attachment. This is the key point. Here, support attachment. So maximum horizontal. These are the key. Maximum horizontal dwelling unit. So from the overhead, so first of all, we from the whole of this words and this question, we can understand that we need to go to the section 6 because of the service, because in the Canadian Electrical Code Book, everything about the services is in the, if you are lucky, everything can be in this in the section 6. You can find them. But it's about the support attachment, dwelling unit, maximum, and also overhead service, and also horizontal distance. Let's go to the section 6. Section about the overhead, find out about the overhead, method of termination, conductor, consumer service. It's about the consumer service also. It's about head, over service head. Yeah, it's about consumer service, service head, and it's about its location. Its location minimum 150 millimeters and maximum 300 millimeters above. But this one is horizontally. 600 is horizontally support attachment. So the answer is 600. Oh, we don't have 600 in this question. It's about horizontally. It's wrote horizontal distance, maximum horizontal distance. 150. This one is minimum and this one is the maximum. 300 is the maximum horizontal, maximum. The question is 300. It can be the answer, but it's not the answer. I think this question is not correct. If we change it to 600 meters, it is the answer, because it's talking about the horizontal distance, not the vertical, because this one is the vertical distance. So from the support, first support of the service head, overhead service. So let's mark this one as a correct answer. Okay, that's it. Question 20, question 90, it was the surge, low voltage surge arrestor. This is about touch and step voltages. You can find them in table 52. This is the important that know what is the table 52. This one is about the submersible lake ground fault protection. How much is 10 millimeters? This is the limitation of the accessible amperage, just 10 milliamp. Separate consumer, not above one another. Yeah, they cannot be above, but separate entrance. For what? For the two supply services. Also TC cables, they don't have bounding conductor, so we need to use separate bounding conductor. What is this? This is a CT current transformer. We use CT current transformers as a measurement instrument for measuring the ampacity of high ampacity wires. What was this certified? Oh, the organization that can approve the electrical equipment, electrical drawing for the location of the receptacles. What is this question? Large consumer project, weekly meeting. We need weekly meeting, written approvals. When we have the voltage of the load, the power of the load, the consuming of the load can be it should divide by 4 and diode. What is the diode? Cathode, anode, positive, negative, low forward. In forward direction is low, in reverse is high, the resistance. Wood to concrete for power actuated fascinating tools. And what was that? PLC software is a logic diagram. I would like to make a video about the PLCs and about their logics and also about their schematics. And also what is the NPN and PNP if you need a short video, maybe I can make it 1 hour. In 1 or 2 hours I can teach you about the PLC, everything about the PLC that you need in this exam, more than this in this exam, and it's good. If you need know about the PLC. If you need to see a video about PLCs in my channel, please write a comment and ask me for making this PLC. I'll try to make it faster. But also about the transistors. If you want to know more about the transistor, I'll make a video about them and describe them. NPN transistor is a negative transistor, and so it has cathode, anode, and also cathode in this transistor. So it's only 2 terminals. It's not correct for a statement about the transistors. This is table 2D2. Table D2 give us the 165 amp, but it's not correct because we have the enough information depend on the node of this table D2, node 2 of this table. We have enough. When we have enough information in our situation or in this in our question or in real world, we don't need, we shouldn't use that table. We can use this method to calculate the right ampacity of the. This is about the load. We calculated the load of 3-phase. We have 3-phase load. That is because they told us 3-wire system, so it was delta connection of the load, and it was 15 kilo. We have 5 kilo volt ampere of every part of the load, and also it is about the stator and rotor of the induction motors, and the speed of the NS is the speed of the magnetic field of the stator, and also we have a phenomenon about the S. What is the S? Is slip. Slip is the differential of the rotator, mechanical speed of the rotator, and also magnetic field of the stator. And also this question about the panel sizing in the secondary side of the transformer. It's easy question. These are easy questions. Just need to divide the power of the transformer to the voltage of the primary or the secondary and size it, and that's it. Thank you to be with me in this video. I hope that you can pass the exam and learn more in my channel. You can go and see more videos about the exam, and also phenomenon about the electrical engineering, electricians, everything in Canada, about the rules, about the and I will be happy if you put comments and ask me what you need in your real life, in your real job site. And yeah, if you need more questions, if you need more courses, I can teach you online courses. Ask me in comments or contact to me with email. I'll schedule a time for you. I have some students that they're working with me for the exam. I hope that all of you can pass the exam, and this exam can help you to improve. And also for apprentices, they can learn more, and when they have learn more, they have more information about the electrical engineer, about the electricians, about the electrical phenomena in Canada, North America, voltages, transformers, what are the distribution systems, what are the dwelling units, apartments, control panels, circuit breakers, overload control panels, and industrial. If you are talking about PLCs, about this about the contactor, about the overload devices, about the start, stop, and the jogging switches, everything. So yeah, you can contact me for more courses and learn more about. And after that, I hope that we can pass this exam and also another exams and get more opportunities in your life, in your job life. Thank you. Bye.